What's up, everybody? It's ET. It's what, Tuesday night, and yeah, we're gonna do a little more streaming today. So today in class, teacher introduced something called Novelty, and this like blew my mind when I was doing when he was saying it. And so it's basically a planning optimization, and it's pruning branches that you don't really need to go into. It's a little bit expensive, but it's really supposed to reduce the search space a good bit, especially for like game worlds like he did Wumpus World, but I think it applied just fine here in Sokoban too. So we're gonna take a look at it. So that is what I plan to do today. Um, yep, and it's only 2 more weeks of class for this class, so I really shouldn't be doing too much of planning after this. So maybe good for those that don't like the planning part of this stream, but yeah. Anyway, let's keep going. So this is gonna be under Eclipse. In fact, I could probably just use Source Tree. Oops, that's not Source Tree. Where's Source Tree? Source Tree. And then under Source Tree, I think I'm gonna do the 2015 planning. I'm gonna fetch whatever's on the server, and what I'm probably gonna see is this huge thing of like everyone's updates. Whew. So yeah, a lot of work's been being done on here. I am gonna grab the master. Alright, grab the master. Alright. Cool. So now if I go to Eclipse, yeah. I hope. I gotta check my bit rate. Hope I'm not streaming way low bit rate, because I was having trouble earlier. One meg. That's not too bad. I'll try to remember to bring it up later. Alright, so Eclipse came up, but it came up on the other window, so I'm bringing it here. Alright, lordy. What is going on? I'll let it refresh everything. Or should I add new projects? How do we import projects? Import existing projects. Yeah, right? It should be this folder. Oops. Alright, let's just grab this. And yeah, grab those planners I don't have yet. Alright, iterative with planner. So here's the code. Planner is good. Search is just a normal search. And novelty. Alright. So it has no comments or anything, but that's okay. What I'm gonna do is I'm just bring this straight into. Oh my gosh! You know what I realized? I'm making changes on the Sokoban project, but it's different than the set I have here, so that's a problem. So Unity, this planning is different than this asset planning. Oh my gosh, yeah, that's gonna be a mess. IDK. This is what I'm gonna do. I might regret this later, but I'm gonna go here, go to my this is my assets, my scripts. I'm gonna delete this, maybe, and then I'm gonna go to Unity, Sokoban, and go to Assets, Scripts, copy this, back over to this thing, Scripts, paste it here. Oh gosh, I hope that worked. Now I'm gonna go to this planning project, and I'm going to just see if it still works, maybe. Nope. Let's see what's the problem. Fact Gatherer. Okay, so we don't have Fact Gatherer. Fact Gatherer is in this planning. It's in heuristics, and here's the Fact Gatherer. Okay. So heuristic search planner. Fact Gatherer should be able to just alt drag it up in here. Fact Gatherer. And hopefully you know what's up now. Okay, it's diagnosing and doing a whole bunch of stuff. Cool, so it seems like it's working. So I'm gonna stop it here. I'm gonna make a zero problem here. And so the zero problem is gonna be a very simple domain. So this is kind of a complex domain, not too bad, but we know we can make simpler. So if I hit play here, oh, I just realized the music's not playing anymore. It's one of these windows, right? Is it Chrome? Chrome, here we go. So if I hit view PDDL and I go to that Unity folder, the Sokoban Unity folder, there should be this new problem that should have been written today. Maybe I didn't hit view PDDL. Alright, there we go, that's written today. Copy that over to planning. I guess here in planning and benchmark. Hey, where's this problem? It's in, oh, it's in the resources. Okay. So back to here. You're not in here. You're in the assets, resources, problems. I'm just gonna make a Sokoban problem 0. Hopefully you accept it. Actually, more importantly, you know who needs to accept it? This guy. Planning. Yeah. Alright, so Sokoban plot problem 0. Copy if newer. And then, yeah, this is a smaller domain as you can see. So that's great. I'm happy with that. We hit it to 0, hit play. This should load a lot faster now. Ba, 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 ba. And here we are. And basically, hopefully I can hit like F6 twice or F10 twice, and that should find a plan relatively quickly. Yeah, there we go. And the plan is, yep, 5 steps. So move cell to 0, 0. Yep, move there. We'll push the box, move it again, move, and then push the box one more time. Cool. Yep, so that is the plan for sure. Let's see what this novelty stuff is. So I'm gonna just add it to the heuristic planner. And I don't know what we called it here. Novelty, okay, cool. Okay, so I'm gonna make a new item here. We'll call it novelty. Yep. Let's go ahead and make it public. Public class novelty. Let's see what we got here. Just copy this stuff. Yep, we're just converting this over to C# code. Let's say has novelty, state space problem. Yep. Good, good, good. Is it capital? Hmm. I'm gonna figure this out. Yep. Conjunction dot length is a, yep, it's gonna be length, like that. Alright. Return ever. Alright, so ever is this. And it's gonna be a bool. So that function is now good. Node dot state is good. What's a test? Oh, yeah. State. You don't know what a state is. Using planning, please. And bool. Okay. And this is a for each statement. For each literal in conjunction. Literal. Alright, cool. So that's not too bad. The only thing we're missing here is this literals definition. So I'm going to compare what the problem is here. Where is this? Problem.literals, F3, state space problem, collect steps, collect literals. You see, that wasn't there before. So I'm going to go ahead and grab that. Where's our problem? Our state space problem. That's here. State space problem. So this shouldn't be too bad, I hope. Enumerable, I guess. Maybe enumerable. Ooh, tree set. Lordy, lordy. What is he doing here? Let's go with list for now. And maybe this will work its way out. List of literals. Fix this code. Alright, let's go down here. Collect literals. An I collection. We're going to say is literal. Is this. Add that. I'll worry about that in just a second. Unsupported operation. What kind of invalid operation? There we go. Oh yeah, here we go. And we have another for each in here. For each. Okay. Something a little crazy. So return literals. What is literal? A list of literal to array. Do I just say of literal? Is that the wrong type? Oh. Okay. That to array. Did that work? Awesome. Alright. Phew. So that is the list of literals. I don't know exactly what you're doing. Yep, that's exactly what I did for my fact gatherer. Lordy. Alright, well, either way. Alright, so now we got the collect literals. Let's go ahead and put that in the constructor. Where is this constructor? Here we go. Whoa, we did not copy that. Alright, so we can just say literals. Oh, we didn't get that part either. Alright, so we got literals and steps. Cool. So I like it. And just right quick, how does the collect literals work again? Sup, Chorito777. Thanks, man. I'm doing my best. More doing my final project than I am doing code for the game, but you know, oh well. Cool. Hey, Alan and Ethan. Man, I'm just coding. So nice seeing y'all. Alright, back to this. Alright, so we got all the literals, we got all the steps. So that's cool. So now we'll be working on this novelty function. And so this novelty function, what it's going to do, it's going to be able to prune some of the options we have when we're trying to find a solution for Sokoban. So, and this code is just there and it works, so we'll see. So I'm basically importing code from Java over to C#. So what else? What else am I need to do in? Novelty. Alright, so that's cool. The next part is this part. Alright, so we're pruning. Alright, so I'm going to try to convert this code over to what I have for HSP. So I'm doing a little more than what that code is doing, because I'm doing the HSP planner and I'm doing novelty. So, okay. So that find solution, yep, we're dequeuing it. We're expanding the node. If it's cool, then return the node. So here we go. This is where I gotta do it. So if not prune, then you do that. And so now we gotta make this new function called prune. So I'm gonna go ahead and make it. So there's that function prune. I will make it more C#y friendly, so capital letters for the functions. Alright, and so this is what the recommendation is for pruning. Is we use that novelty function, and I think it's going to be has novelty. Max width. That must be something we're setting elsewhere. Okay. For now, we'll just do it here. Hey, yeah, this should be called node. What's wrong here? Cannot convert from planning to state space problem. Okay. Well, let's figure that out. Alright, so problem. We could just cast it, because we are guaranteeing that this is a state space problem. Yeah, that's what I'm gonna do. Alright, so I've never done this before, so we'll see how that works. So basically what this eliminates, or what it's pruning, is if you're going back steps. So like if you move over this way and try to move back, it's supposed to prune that, so you don't actually even have to evaluate that. So we'll see. First I'll just do a quick speed test on this. So for me to do that, I'm going to just hit play. And it should stop here at the HSP part. And I'm going to jump in here and just kind of go through all these lines of code right quick. That seems fine. Okay, so this next part I want to go to anyway. Alright, so I think I'm going to do this prune function once just to see what it does. Alright, so max width equals 2. Has novelty. Oh, so it's going to return false. So it hits that function pretty quickly, actually. Not bad, not bad. Alright, I feel good. Let's just continue. I might just finish the program, which is okay. Ooh, that's taking a little bit. The domain's not that hard either. It must be stuck. Yeah, this should not be taking this long. Alright, I'm going to stop it. Let's go to the benchmark. I'm going to see if it even gets a plan. Start. Yep, that's good. Continue. Then F10. Alright, give it a second to run. Alright. Cool. Yep, that is doing just the opposite. It is taking forever. So that is not what I want. So if I go back to HSP Planner and delete this off, will that run a lot faster? Yep. And yeah, you see that ran in like no time. So something is awry. But I don't know what it is. Guess we'll have to look into it. Alright, novelty. Let's figure out what it's doing. That's step 1. Okay. I don't know. What the dealio? Let's look here. Novelty. When we run this planner, we just say, hey, 2. 2 is our max width, and then it just does all that. I think I'm gonna just have to walk through the code or step through it. So let's do it. Let's get rid of everything else but benchmark and step through this code. Actually, while I'm here, fact gather no longer needs to be fact gather. We can just say literals, all literals. Is equal to problem dot literals. Okay. Oh, it's a mutable array. No problem. I think that's the best way to do it. All steps equals problems dot steps. Alright, there we go. So we got all the steps, we got all the literals. Man, that was so much easier than what we did earlier. What's next? So we got all the literals, all the steps. So that should work just fine. Whoa. Are there duplicates? Interesting, interesting. There might be duplicates in that literal. That could be a problem. Let's look at our state space problem. Sorry, he's making a new list of literals. He's calling this function again for the initial. Collect literals, okay. Oh, I think I like my fact gatherer better here. I know it's longer. But you don't have to go through all the steps, which is nice. Okay, forget what I did here. Hopefully you remember what was here. Yeah, that's much better, I think. Alright, cool. Now let's go to our novelty. And I'm just gonna put it right here. Oops. And you should be a list. And now that you're a list, I guess you gotta be count. And I guess if this, you have to be I, like that. Alright, cool. No problem. Yeah. Alright, good. So we're still using our fact gather. Okay, oh, I closed out the chat. Let's see. Papa's laughing. Nice. Alright, so what am I really doing here? Well, I'll go ahead and make this capital. And make this capital. And make this capital. Alright, so that's nice. But the problem here is it's not working, right? So if I go to my HSP planner, okay, that's still commented out. So hopefully this works again. Alright, so we're here. And if I hit F10, the plan should come up pretty quickly. Nice. Okay, so that is the HSP planner still working as it should. Now let's walk through the code with this pruner thing to see what's happening. Play. And while it's playing, I just want to see something. Okay. Nothing for me to worry about right now. Alright, so I'm going to jump in here. First node is nothing? Well, you should at least have a state, right? Yeah. Alright. It's not the goal state. If you have children, great. So my first child is move player to from 0, 0 to 0, 1. Alright, so we shouldn't prune this. I know that because nothing's ever happened yet. So that's good. And we shouldn't prune that because that's never happened now. Okay. Now, this is where I'm curious. Alright, so the child is moved back to 0, 0. So I want to say this is going to get pruned. So I'm going to jump in here. Or, you know what, I'll just let it go. Cool, so it got pruned. Push box, that doesn't get pruned, and that's great. Alright, so no children in here. So now we're going to move the player back. To 0, 1. So I wonder if that's going to get pruned. Doesn't? Okay. Yeah, because the box moved. So basically the whole thing's got changed. I think all of them should be added at this point. Alright, so it seems to be working okay. One second. Yeah, I'm back. Sorry. Okay. Oh, no, jump out of there. I didn't want to get in there. Alright. So you're adding a whole bunch of children. Here we go. Node. This node. What do you say? You're going to be move player, push box, move player, move player. Okay. So. Whoa, whoa, what happened? I don't think that was right. Oh, actually, maybe so. Might have hit F10 too many times or something. Alright, so what do you say? Move cell, move it up, and then push the box over, move the player back down, move him over, then push the box off. Yeah, that's the right plan. So that's great. So I'm going to continue this. Start it up again, one more time. I'm going to hit F10. Nice. And that's it? Okay. Let's see how it handles a harder problem. So diagnostic is running. 3, 4, 5. Actually, I should just let it run all the way. 6, 7, 8, 9, 10, 11, 12, 13, 14. What are you doing to me, man? You worked just fine a second ago. Ah! It drives me crazy. Alright, hit play. I'm going to let it run for like 10 seconds, and if it doesn't solve it, I'm going to try to figure out why. Huh. Feel like it was just working. Takes like 4 seconds to do everything else. And then you jump in. I wonder, when should I check to see if the problem has the goal? I guess before expanding, right? Let me see. I'm gonna jump in and just see. Is the state... Oh crap. Okay, yeah. So if I just get the node, is the state already kind of ready to go? Yeah, so I don't think that's changing. Is that right? Yeah, the node doesn't change, so don't expand the last node if you don't have to. So that's a good thing to do. Alright, so we definitely need to move the cells. Oh. This is the harder one anyway. I don't remember where we started, so let me back up. This is where I kind of want to start when I'm debugging all of this. So I'm gonna benchmark. I don't actually care about this part. I'm more worried about the code inside of the HSP planner. Alright, so here we go. Where do we start? What's our initial... If I look at our state, our literals, our literals has player at cell 1-1. Alright, so good to know. So 1-1. So you're going to move from 1-1 to 1-2. Then you get the cost, which will be a little pricey to get with the HSP, or you can move it to 2-1. Alright, good deal. And this is the hardest part. So you can see the novelty goes really quick, but the getting the cost of the child is kind of expensive. It's alright. What's this next child? It says, hey, why don't you move it back to 1-1? We should prune that. Don't worry about that. Right? Oh, but it's freaking out here. I wonder why. Why is it freaking out here? Well, at least we know where it's freaking out. So let's dig in, I guess. 5, 4, 3, 2, 1. Beep, 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 beep. Alright. So when you're moving back, basically, is when you're having the issue. And that's what Novelty is here to help. So here we go. This first child is, yeah, let's move back. So I'm going to jump in. Oh. Okay, so here we are in the prune. So we're going to say max width equals 2. Jump in here. We have all the literals, so I don't know why I gotta gather all the facts again. I mean, I don't. That's the idea. Alright, let's figure that part out. We already have all the literals. So I'm going to somehow pass that. Yeah, pass it right here. So back to Novelty. Screw that. Yum, 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 yum. State space problem, node size, list of literals. Okay, so we have the literals. HSP planner. Um, be my guest. Please pass the literals here. At least now that will be a little quicker. I mean, it's quick enough. I mean, but now we don't even have to get all the literals each time, which is even better. 4 seconds about. Yeah. Alright, so here we go. This is the moment of truth. We're moving back, so this should be pruned, so I'm going to jump in. Max width, we're going to do it for 1 first. Let's see if it crashes on us. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I paused it. Okay, let's stop this. Alright, here we go. That part's fine. That part's expensive. 1, 2. This part's fine. This part's expensive. This part is where we get stuck. Alright, so literals, no problem. Oops. Jump in next time. Jump in. Jump in. Alright, index, does index equal conjunction length? No. So you're going to say, hey, for each literal, is this true? Nope. Is this true? Index does not equal conjunction length. You just basically find the next pair. So alright, what's our conjunctions that we're looking at? Not adjacent cell 0, 0. Okay, I'm just curious. I'm just gonna figure out what this is doing. Node equals null. Doesn't. If node test. And then you're just gonna say for each literal. Okay. And return true. And if you return true. Okay. If you return not true, oh, you return true, I guess? False, okay. So basically, we're just gonna run through this. So I'm just gonna let it run. I mean, I don't know what else to do. I'm gonna just kind of pause it at different points. And then continue. It's definitely doing stuff. Pause. What's our call stack? That's what I need to see. Are we still in Novelty has Novelty? Yeah. So we're in that one, and this one. Alright, time to get serious about this. Let's how big is problem 1? I don't even know. Problem 1 is 5 by 5. Okay. Crazy. Oh shoot, is our timer not really going? My bad. Yep, let's do what I'm kind of dreading doing, but should do, start diagnostic tools. Let's run as a release and start it up. Please run it. And as you can see, it's running. Whew. And we gotta see what functions is really slowing this thing down. I might give it 30 seconds maybe. Alright, I am going to, maybe at a minute I'll stop it. Maybe it'll stop itself. I just feel like it should be working. I'm closing it. Alright, so we're mostly using the equals thing, and that's taking up tons of our time. But it won't tell me who's calling it. But we are running a lot of equals and is trues. So let's see. Let's go here. Alright, heuristic panel. Alright. Has novelty, 168. Test is not very much, and ever is not that much. But something's got to give, because something's really hurting here. So this code seems, yeah, that should be fine. You're just calling another function. These seem fine. Test. Doing a lot of is trues. Alright, so where are we doing equals? That's an equals, but not the literals. There's another is true. You know, I guess when we're doing the is true, that's calling the equals. Alright, yeah, so that contains is doing a good job there. Yeah. So let me think about the novelty. The novelty just says, hey, if there's anything that's changed. I guess without the novelty, how fast does this problem get solved? And maybe it just doesn't even get solved. So I took out novelty by taking out that line. I'm just gonna run it with the debugger. So by now we should have at least gotten the state space problem, and now it's just kind of doing its normal search. And oh yeah, well that goes. I think I can tell you how big that domain's gonna be by going to Sokoban. Okay, I was just making sure I didn't finish. Sokoban, there we go. So without the pruner, it's that fast. 5 by 5. Should have 16 250 grounded steps and 2650 facts. Okay. Here we go. Yeah. I feel like that is working pretty well. So back to planner. It takes, okay, so this is a 30-second problem ish. So this novelty should really be helping us out somehow, but it's not. But we'll figure out why. Maybe it's this iteration. What if I just did 2 right away? Alright, well, I think that's part's okay. State space problem. Or benchmark. State space problem. What am I looking for? The novelty, sorry. Yeah, novelty. Yeah, so that code should be running fine. This should be fast. Don't know about that. We'll look at that in a second. This should be fast. The is true should be okay. That part should be okay, and then the has novelty is just calling this again. Alright, and the ever. So ever, we're just saying, hey, if the node equals null, test, yeah, and if node dot parent I don't know. I was gonna try to cast it, but maybe that's not the best thing to do. Alright, so then we test it, and then we're just gonna say, hey, for every literal in conjunction, check if it's true. And so these is trues I think are hurting a little bit. Gated literal is true. I'm confused. I'm sure this code works just fine. Proposition. Alright, so the proposition, if it's a negated literal, then we just say not is true. Okay, basically just not this. I don't know why I cast it. Oh, because I get the argument. Oh yeah, so we're getting the argument, and that's why. Okay. And the argument is what? An expression, and then we just say, hey, it's really a literal. Yeah, that makes sense. Okay, I'm cool with that. Alright, blah 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 blah. And then otherwise just see if it contains that literal. Literals is just a list. Literals is a list. Alright, great. So that's this kind of expensive, but shouldn't be too bad. But I guess we're running it a gazillion times. Yep. Yep. Alright. I feel like there's something else missing here, and maybe I just don't use as many. Let me think. So we have a list of literals. We're never actually modifying this, right? So literals. What about this literals? Literals. We're not modifying it in any way. Neither the node. Alright. I am just done looking at this. Like, it seems to be working. But what's... Alright, so if I played this... Here we go. Let's just do two runs with this. This is, I guess, with the pruner. 1.5 seconds. Novelty, HSP planner. Alright, this is without the HSP planner. Less than 1.5. Yeah, I don't really know. I might have to look into Novelty later. So we got the Novelty in there. I'm just not enabling it. Yeah. So I'm okay with all of that. I'm just gonna leave this commented out. And this is just a use novelty, uncomment to use. Alright. I'm cool with that. But for now, we're going to see small state space searches. Okay. Blah, blah, blah. Okay, I think that's all I'm going to do today. Sorry for kind of just spacing out a little bit. I'm just trying to figure this all out. So, it was a good try to use novelty. But alright, next time what we're going to be doing is continuing on with the ghost boxes and everything. So, I'll catch you guys next time. Bye.